some of you might have seen the talk by Alex in the morning, where he already hinted that I will talk about more details of Solidity 0.5.0. The 0.5.0 is a breaking release, and I would say it's the first big breaking release we had for Solidity, where we hopefully fix many of the weird edge cases of Solidity. And our design goals for Solidity 0.5.0 were we want to make it safer, so we don't add too many features in this breaking release, but we mostly restrict the ways in which the language can be used. And we require the user, the programmer, to be much more explicit in many more areas. And we also try to remove disambiguities and weird behavior. And some runtime checks. Runtime checks are always are good and bad. So they are good because they prevent bad things from happening. But they are also bad because they are usually more costly. So they need code to be run. So the deployment cost is higher, but also the runtime cost is higher. And they might even lead to security incidents, because a runtime check, so the only sensible thing you can do with a runtime check is to revert the transaction. And this might lead to a contract getting stuck. And in some cases, that might even be worse than just going through with the error. OK. And because of that, it's even more important that all of the users of Solidity are aware of these runtime checks that happen in some situations. OK, so let's start with some code examples. This is a Solidity contract written for Solidity 0.4.0 or 0.4 whatever, and it's a very simple contract that just sets an owner and then allows you to withdraw money. And this contract has at least one bug. And this one bug also happened in the wild. And the problem is that, I think the previous talk also quickly touched on that. The problem is that there is an initialize function, which is called in the constructor. But it doesn't have a visibility specifier, and because of that, it's publicly visible by default. And this means that anyone can reset the owner even after deployment. And we make this easier by forcing the user to explicitly specify the visibility of all functions. And then you have to think about, do I want to make this public or not? And if you make it public, it's explicitly visible. And now you created this contract, and you wrote the contract, and at some point you decide, my contract is perhaps a weird name, so let's change the name. And then you might forget to also change the name of the constructor, because the constructor of a smart contract in Solidity is identified by having the same name as the contract. And this also happened in the wild. And because of that, we changed the constructor to be written with a special keyword here. And now you can rename the contract without changing the nature of the constructor. And the third thing, so here at the bottom, there is a function call for a function called withdrawn. At least it might seem so. In reality, it's just a call to the event here. And to make that more visible, we force users to use the emit keyword in front of every event call. That's another example that also happened in the wild. Alex already talked about this example in the morning. We have a very simple for loop here that just sums all the elements of an array. And if you take a closer look, you might spot a bug there. And the annoying thing about this bug is that all your unit tests might be perfectly fine, because it only happens as soon as you supply an array that is longer than 256 elements. If you do that, this loop will be an infinite loop, because the compiler infers a type for I here, and this type depends only on the first value that is assigned to the type, and the type of this first value is uint8. And if the length is longer than, or is larger than 255, then this will result in an infinite loop. So we disallow var, so type inference is completely removed from the compiler. You always explicitly have to specify the type of everything. And another thing is that Solidity has the concept of data location, which can be either memory, storage, or call data. And this is quite confusing rightfully so, quite confusing, especially because the default values depend on where you declare the variable, and we decided to scrap all that and just require the data location to be specified explicitly for all reference types. So you always have to specify memory for function parameters now, and the same for local variables. Then another bug that is always named as some prominent example of bugs in Solidity is the failure to initialize storage pointers. So here we again see an example of that, data p. You might think that this is a temporary variable that is just created, but it actually is a pointer to storage. And if you do not initialize it, it's set to 0, which kind of references the length of this array, which is not at all what it should be. This has caused a warning earlier, so people should already be aware of that, but with 0.5.0 we force this to be not possible at all anymore. And the thing that is not possible at all is to declare p without assigning it from somewhere. So this problem is fixed, but the fix, you can do it like this. So you have to assign p from somewhere, so you first have to create a new element in this array by increasing its length, and then you take the last element in that array, assign it to your storage pointer, and then you can set the elements. This looks very weird, so we do not plan, so we have a fix for that, but it won't be part of 0.5.0, but hopefully of 0.5.1 or 2 or whatever, and the fix looks like that. So storage arrays will have a member function called pushNew, which creates a new element at the end of the array and returns a reference to that. So if you assign it to a variable and you assign these members of the variable, these values will be put in the last element of the array. You can also directly use participants.pushNew.name equals something. Good. Then, another thing that was, something that was inherited from JavaScript and was quite annoying for some time. Alex also talked about that shortly. Is the function scoping of variables, and especially the variable hoisting. This code is valid Solidity code. So a variable declared anywhere inside a function is visible in the whole function and from the start of the function. So assigning 3 to I works here because it's declared somewhere here. So we decided to just take, Solidity is a curly braces language, so we just decided to use the scoping rules from C99 or C++, and this is basically block-scoped variables with the single exception that if you declare a variable in this initializer part of a for loop, it is only visible inside the for loop and not outside. So this is probably the usual rules you would expect from a curly braces language. This is valid Solidity 0.5.0 because the I that is declared here is not visible outside of the for loop, so you can declare another independent variable I for the second for loop. In 0.4.0, this would at least cause a warning or even error, I think. Another good thing about that is, so in 0.4.0, you would have either declared I only once and used it for both loops, or the second option would be to just declare a different variable for the second loop. But if you declare a different variable for the second loop, this takes another stack slot, and you might run into the stack too deep error. And we implemented the block scoped variables in a way that the stack slot is actually freed at the point where the variable runs out of scope. So this might save you, or this might allow you to increase your kind of stack size or number of local variables available to your function. Okay, then I have some more changes without examples. The push new I showed to you earlier has an equivalent for removing the last element from the A array that is called pop. And probably in 0.6.0, we might even disallow assignment to the length property of an array altogether, because that causes problems with unpredictable gas costs. Two other features are access to the ABI encoder and decoder. This is probably quite useful for proxy contracts or just, passing data around in smart contracts. So the encode, there is a whole family of encode functions because we have at least the proper ABI encoding and the packed ABI encoding, and then there are two more encoding functions that also take a function signature, so you can take the byte array and directly pass it onto a call function. And the decode function is written in a way where you pass a tuple of type names here, so that this might look a little weird on first sight, but I hope that it's quite practical to use. Then another feature that was often requested are enums and structs and interfaces. So I think this will be quite useful to define more readable interfaces and make interfaces actually useful, I hope. Then we still have some minor safe changes. So the changelog that we currently have is 3 pages long, so I can't explain every single feature, but I hope all of them will be useful. Call had some very, very weird edge cases, and if you don't know all of them, then it's kind of not predictable what it will do. So we try to remove all that and change call so that it only takes a single bytes parameter and just uses that as the call payload. And you can then use the ABI encode functions to generate this payload. Tuple assignments had some. So in 0.4.0 or in 0.4, it was possible to assign tuples to variables without specifying all the components. So the last component was some kind of catch-all thing. So you could take a function that returns 5 elements and then assign that to only 2 variables, and the compiler wouldn't complain. Now the number of components have to match exactly. Interface functions have to be external. This is quite an easy change because interfaces are meant as external interfaces and not interfaces to be inherited from. And this conversion thing is also an interesting change. It was prompted by some competition somewhere that says, here, look at this Solidity code, guess what it does? And the problem here is that if you have, so bytes 1 is a kind of byte array of 8 bits, And uint8 is an integer of 8 bits. And apart from the allowed operators, the only difference with them is the alignment. Integers are always right aligned, so low order aligned, and byte arrays are always left aligned, so right padded with zeros. And of course, you can, I mean, it's kind of logical that you can convert between those. But it gets interesting when you, and also the expected value is obvious, I hope. And it gets interesting if you convert between such byte arrays and integers of different sizes. So for example, you have a uint16 and a uint8, so an 8-bit integer, and convert it to a bytes2, so a 2-byte array. And now the question is, on which side does it pad? So how does the shifting work? And to make it clear how the shifting works, we basically disallowed these conversions when the sizes are different. And the reason is that, so if you want to convert uint8 to bytes2 now, you can either go through uint16, which pads on the left, or you can go through, so convert a uint8 to a bytes1, and then to a bytes2, and that pads on the right. OK? Good. I mean, I think it's at least a little bit clearer. I'm not sure if it's all clear, but I think it improves the situation at least. Now, so another change, right shift on signed integers actually shifts. So this was a bug, I would say, because we implemented right shift on signed integers by signed division, which is wrong. I think nobody actually used it, so it's not too bad. And another change is non-pure constant state variables are disallowed. The previous talk also spent some time on constants. And the reason why they are disallowed is because constants are not actually constants, but more like macros. So the value of the constant is put in every place where the constant is used. And now we force these values to be pure, which means they do not depend on anything. And this allows us to make them actual compile time constants and put the value there. This is not what we do already, but at least we can do that change without changing the semantics. And then for major safety things, view and pure functions, when you call view and pure functions in 0.5.0, it actually uses the static call opcode. This causes some problems on testnets because static call is only available starting from Byzantium. And if you run a local testnet, it usually defaults to the frontier EVM. And then people get reverted transactions and don't know where that comes from. So this is usually the cause. Set your testnets to Byzantium. And a similar change you have to be aware of is that the ABI decoder now reverts if the call data is too short. So if you expect a uint8, if you expect a uint parameter, but you don't give any data, then in 0.4.0 it would have just used 0. Now it reverts. So this is also something you have to take care, especially when you write proxy contracts. And one special case is that most people do not know that the ABI specification says that byte arrays have to be padded to multiples of 32 bytes. And this might cause a problem here. So even if you only have 3 bytes of value, you still have to add enough zeros so that it's padded to 32 bytes. Actually, I'm not sure. It might be that we don't revert in these cases, but better be aware of that. Then inline assembly, we will enforce strict mode, which means we do not allow, for example, jumps anymore. So jumps and labels are gone. And the reason behind that is that we want to make the transition to EUL as an intermediate language. And EUL does not have jumps because we want to target different different backends, and jumps are not always possible there. So for example, in WebAssembly, it's very hard to make jumps to labels. And when we know that there's no way to generate such code, not even with inline assembly, then we're free to compile to WebAssembly. And one tiny last thing, the continue operation in a do-while loop had a bug because it directly jumped to the next loop iteration without checking the condition. This is something that was only noticed, I think, 1.5 years after its implementation, which kind of also hints that nobody used that, so it's fine to do that breaking change. Yeah, so